There, you should see um, a shark with a frickin' laser beam attached to his head. Okay, Lou's giving me the thumbs up. Here we go. All right. Laser cutting. There are three basic types of laser cutters engravers. Um, the diode laser, which is the newest and least expensive kind. The CO2 laser, which is the most common kind and can be found in anywhere from home workshops to industrial applications. And the fiber laser, which is found only in industrial applications right now. The laser that I have is a diode laser, often referred to as a hobby laser. I'm just going to briefly go through the three different types and how they work. A diode laser. They're pretty popular because the price is reasonable. They are similar to an LED. It is exactly a light emitting diode, but the kind of light that it puts out is different. It's very intense, and it consists of a single frequency of light. And multiple laser diodes are used and grouped together to create a diode bank. And then the beam coming from the diode is deflected using mirrors and concentrated using a convex lens so that there is a single spot coming from it. It's very intense, creates it's very high energy and creates a very high heat. So what happens when that concentrated light hits an object, it vaporizes it. The frequency of the light will come into play in a little bit. A CO2 laser is not that much different, except that in order to get the light, we're using a tube filled with gas. And the primary gas in that tube is carbon dioxide. So that's why it's referred to as a CO2 laser. Again, a very intense light comes out of them. You'll see that it has a cathode and an anode, very similar to an LED, or any tube that produces light, such as a fluorescent tube. But the color, the frequency of the light is different from the diode laser. It is also more powerful than we can achieve with a diode laser. And the third type, the fiber laser, again, not dissimilar, but instead this time, in order to increase the strength and the power of the light that's coming through it, again, it uses a bank of diodes, is a very intense fiberglass or fiber optic cable. And the properties of that intensify the light. Now, you'll see here that a fiber laser is capable of a wattage in the thousands, up to 10,000 watts. We don't see those generally in any home or small shop. They are for large industrial use. So, costs and wattages, diode lasers, 500 to 2,000 and above, 5 watts to 40 watts. They generally are all the same kind of light. It is a blue light that is emitted by the diode. They do have some that are an infrared light, and that does a different job. With the infrared, you're not going to engrave wood or anything, but you can mark on metals. Doesn't truly engrave a metal. Neither can a diode truly engrave a metal. In order to engrave a metal, you need a CO2 laser. And when I made this up, the price point was about $500 to get into it. And I'm looking at Canadian dollars now for our American friends. But you can get into one for, I think they're as low as $200 now in the US. CO2 laser, about $600 to 8,000 or more, depending on the size and the wattage. Size is a big thing because with anything, you've got to look at your cutting area. And fiber lasers, again, if you have to ask, you can't afford one. And again, they're just for industrial use. But with a fiber laser, you can cut through anything, and I'm talking about, maybe not an inch thick of aluminum, but you can cut thick aluminum and steel and that kind of thing. And they're beginning to replace the other methods of cutting steel. So what does what? Diode laser cuts wood, cardboard, cork, these kinds of soft materials. You can engrave on ceramic, glass, and you can also engrave on some metals with an ordinary diode laser. And again, with the infrared laser, you can mark on other metals as well. I say engrave, but it doesn't really engrave metal. There is no metal removed by a diode laser, but it can mark them. CO2 lasers can engrave in metal and can also cut acrylic. With a diode laser, there are a few colors of acrylic that can be cut, but because of the nature of the frequency of the blue light, it can't engrave some. In a fiber laser, you can cut metals, anything you would like. Now, it would be remiss of me if I didn't provide you with a warning. Several different kinds of warnings, but the biggest one that people aren't aware of is to not put anything in the laser that you are unsure of. For instance, if you put something like vinyl in a laser, a diode laser anyway, when that is vaporized, it will emit harmful vapors. Those vapors will kill you. Those vapors will also erode the anodized aluminum frame of the laser. And when I say that the vapors will kill you, we're looking at basically what they used to call in World War I mustard gas. And that's how dangerous it is. So if you are unsure of the safety of the material or the makeup of the material, do not put it in your laser. Also, laser light will make you go blind, so do not use it without eye protection. Also, fire is a possibility, so you should never operate it unattended. There's a lot of things to consider when buying a laser, because there's a lot of accessories that you may need. And of course, every accessory that you buy drives up the price. In my opinion, one essential accessory is an enclosure. When it comes to enclosures, I'm on a lot of groups for diode lasers that get ideas and stuff like that. And one of the things I see most often is people building enclosures out of wood, which is a silly idea. An enclosure for a laser should be made of fire retardant material. All enclosures will have some sort of system to clear the vapors out of the machine. There's smoke, but there is also vapor, because remember, we are vaporizing the material. We're not just burning it like you would with a wood burning kit, but you are actually vaporizing the material. And of course, the light emitted will cause you to go blind. And most of the commercial enclosures have a window in them with glass that is tinted to the right, or plastic that is tinted to the correct color, so that you can look at what's going on and not harm your eyes. So my setup, I have a 20-watt diode laser. I have the enclosure with the vent. I have what is called a honeycomb base. A honeycomb base, I'll show you a picture of it in a minute, but what it does is it allows the laser, if you're cutting through something, to pass right through the material. If you have a solid surface under the material that you're trying to cut through, you're going to cause a lot of charring on the back of the material, and you're not going to get a nice clean cut. Extra risers, and one of the reasons for the risers is the rotary attachment, because a rotary attachment allows me to engrave things like mugs and glasses, wine glasses, that kind of thing. And one almost essential accessory is an air assist. And this applies to both the diode lasers and the CO2 lasers, because just blowing air through where the laser light is coming from clears out the path of the vaporized material and allows you to get a cleaner cut or a cleaner engraving as you need. A visual representation of those things. The D1 Pro is the X-Tool D1 Pro is the model and make of the one that I have. That is the fire retardant enclosure. The risers are simple little anodized aluminum things that screw on the bottom. The air assist is really a great big glorified aquarium pump, and lots of them substitute an aquarium pump for the air assist. That is the honeycomb there. As you can see, that it's just a metal frame with a honeycomb shaped material, a steel there, and the rotary tool on the right, which kind of sort of looks like a lathe in a kind of sort of way. So as a visual representation of what it looks like in my workshop, there it is. You can see the honeycomb a little better there. So you can see how the laser can pass right through. That gray block in the middle that says X-Tool is the laser head, as we call it. That material underneath, the laser hits that and can go straight through it, down through the honeycomb, and allows for a nice clean cut. The black tubing that's leading from that is going to the air assist. At the top of the screen, you can see the yellow colored plastic that allows me to safely look at what's being engraved. And to the right, you can see the coiled plastic tubing that leads from the enclosure to a vent that I got going right outside of my house. Now you'll see that there's a gantry that goes across, so the laser head itself moves from left to right on the gantry, and the gantry moves forward and back. Both those movements are controlled by a stepper motor, and if you've ever used anything like a CNC router, anything like that, it's all the same kind of technology, even very similar to a 3D printer, except with a 3D printer, you have a third movement up and down, a Z-axis, as they would say, that allows the 3D printer to work. So they're very common in the way that they work, all of these kind of CNC machines. Now, nothing of this kind will work without software. Now, with the X-Tool D1 Pro comes the X-Tool Creative Space software. And like anything like you buy that comes pre-included with software, it's very basic. If you can recall back in the day when you'd buy a printer, there was some kind of photo editing software that would come with it, but it was never anything as good as Photoshop, but it got you started anyway. For lasers, Lightburn is very popular. And Lightburn will work with a variety of lasers. It's not tied to a single manufacturer or type of laser. It works with most, I think, all of the diode laser manufacturers, and with a large variety of the CO2 ones as well. The Lightburn software is quite inexpensive, less than $100 Canadian, and it has some very advanced features to it. And it also has a design feature in it that you can do some very limited and basic, but, well, not even that limited, really, drawing with it in order to create some projects. Now, if you're familiar with 3D printing, lasers commonly use a G-code file, and that's because there is a relation to all these kinds of tools that are a CNC type that use stepper motors to move some kind of tool in order to do some kind of work, be it a laser, or be it the hot head of a 3D printer, or if you have a resin printer, the plate for the resin printer, or anything like that. G-code is a very common file format. The stepper motors move the tool, as I've explained. It's not important to know about G-code software. The laser software, like Lightburn, it's invisible to the user, and it has a Lightburn type file that is exported to the laser machine. Similarly, if you have a 3D printer, you don't have to deal with it. Once you load your STL into the slicer takes care of it and puts it into your 3D printer. It's important to understand the types of images, especially raster versus vector. A raster file is made of pixels. Any photo that you take with a digital camera is made up of pixels. And you're probably familiar with the JPEG, the GIF or GIF, depending, I don't want to start a fight, the PNG or PNG, bitmap, BMP, and WebP is a very new common one that's around. And those are all raster images. Now, the difference between a raster image and a vector file is that a raster image is made up of pixels. And each pixel has a color and a brightness, etc., in order to give you an image. A vector file, on the other hand, includes code embedded in the file that generates the image. Some common vector image file types are SVG, WMF, EPS. PDF is actually a vector image, CDR, etc. The reason why I include PDF is if you download a PDF, or if you subscribe to a digital version of the magazines, model train magazines that are out there, if you'll note, when you zoom in, you do not lose any clarity of the text. And that's because it is the text is a vector image. And as you zoom in, it is recalculating very quickly and showing you a very clear image. I will give you an example if you haven't witnessed that before. So with a raster image, a GIF, JPEG, PNG, all those kinds, when you zoom in, they will get pixelated because you're seeing the individual pixels. And rather than looking at them from a distance so that you can't notice them with the naked eye, they become apparent as you zoom in, especially if it's a low quality pixelated image. And you'll notice on the right is an example of a vector image, where when you zoom into it, there is no loss of clarity. Everything stays very fine and clear. Naturally, with the laser software, because we are converting our images into files that move the diode laser around, we want to work mostly with vector images. We can work with raster images, but it's a little more difficult to get the results that you want. Vector file software. Adobe Illustrator is probably the most popular, well-known version, type of vector file software. And of course, that's a paid software. If it comes from Adobe, you're not getting it for free, even though they insist that PDF Reader is for free. And if you've ever used their PDF Reader, you know that at every step of the way, they're trying to get you to buy something. CorelDRAW, remember CorelDRAW? It still exists. And again, a paid version. The most popular free vector software is Inkscape. And it is what they call open source software. And it has the free public use license attached to it. And it actually works extremely well. Now, when you use vector file software, there's a bit of a learning curve, but there's also a lot of things that are very common to other types of image software that you may have already used, like Photoshop or many of the free other versions of it. LibreOffice Draw is also a free vector file software. And if you have any 2D CAD software, well, 3D CAD software can do it as well. It can also export vector files. So the Lightburn software, let's go back to that. It works natively with vector graphics. Allows you to draw vector graphics, allows you to manipulate other vector images that you import, and it can convert some simple raster images to a vector. It's not free, but again, very inexpensive. If anyone is looking to get into any laser machine, I highly recommend that you just bite the bullet, buy the Lightburn software from the get-go. There is not much crossover between the software that comes with my laser engraver and the Lightburn software. So a lot of folks say, well, I'm going to learn that first and then I'll try Lightburn. Well, you've wasted your time because you've learned something that doesn't work the same whatsoever. And the greatest thing about the Lightburn software is the ability to separate cut layers and engrave layers. I'll show you a little bit more about that in a moment. First, I want to take a look at the screen for Lightburn. And that's what it looks like. And you'll see the large grid area that you have there. And that's where your drawing appears, your file would appear. That's where you can create a file or a drawing. You see on the left-hand side here, I have some very basic drawing tools. I can draw a square or rectangle, circle, polygons. I can play around with the points on a polygon. I can put in text, that kind of thing. And then with the lower ones, I can manipulate those images. I'll show you more on that as well in a bit. Across the top is just a toolbar, some very common image manipulation tools there for lining things up and arranging things on the screen, grouping things together, deleting things. And on the right-hand side, you'll see that I have cuts layers. And below that, I have a section entitled laser in the dark red laser. And that's where I control the laser head itself. I can pause it, I can stop it. I can do a variety of things with that. So I want to show you next a little bit about how we decide what speed and power we need to run the laser at, because we can adjust the speed at which it moves and the amount of power from 0 to 100% of the 20 watts available to me that I want to put out. Because depending on the thickness of my material and whether I want to cut through completely or simply engrave, I want to go use either a faster or slower, more or less power. But you say, well, I've got a piece of 1/4-inch plywood. What speed and power do I have to go at in order to cut through that? Well, this material test generator allows us to do that. And I'll show you in the next slide what that produces. So you'll see on the left hand, going from the bottom to the top, the numbers 1,000 to 10,000. And that's the speed at which the laser head is going to move in millimeters per minute. And along the bottom, you can see we have a power range ranging from 10 to 100. And at the top, it says the interval, which you are not concerned with, and the number of passes. Because the other option we have is we can make the laser pass over the same area more than once with the same precision. So if I'm using a thick piece of material and I want to cut through it completely, even if I go very slow at a very high speed, it may not cut through entirely, but I can pass again if I need to. So if I ran this on a piece of material, it is going to indicate to me what speed and power I need to use to either cut through or engrave that piece of material. And here we go. This is just a very inexpensive and thin piece of plywood. And you can see that at the 1,000 millimeters per minute, anywhere above 70%, and I'm going to cut right through that material. And if I go at, say, 30% at 10,000 millimeters per minute, I'm not even going to make a mark on that wood. So with this in hand, and once I want to actually do a project, be it either engrave or cut right through, I've got a good idea of what the speed and power needs to be. Now, if I had run that and I didn't cut through any at all, I would then do another material test at 2 passes, and I would increase until I get the results that I want. So, as an example, this is a quick file that I did to get the footprint of some structures that I want to put on my ON30 module. I needed to know what the footprint of the structures were going to be in order to lay my track and have enough space and etc. for it. And what I can do here is I can demonstrate to you the layers. You can see that the outline of the 3 structures is in black, and you can see that that is in line mode. Okay, so that is just going to do a straight line at 2,000 millimeters per minute at 85% power. Okay, now I'm doing this on cardboard, and by running the material test ahead of time, I know that that speed and power is going to cut through. Now the blue is text, and that's on another layer. It also is a line layer, and this time I have upped the speed to 5,000 and dropped the power to 80%. And from my material test, I know that that will not cut through the material, and it will simply put a nice dark marking on it. Instead of a line, I could have also asked it to engrave that. So instead of an outline of the words, I would have had solid, but that would have taken a lot more time. And in the next slide, we can see what that looks like. We can see that it's cut the cardboard out completely in the outline, and that I have an engraving on there that it tells me which piece of cardboard is which. So I don't have to write on it or anything else. Now, you might ask, well, how long would it take to do that? If I'm using those speeds, 2,000 millimeters per minute and 5,000 millimeters per minute, we're looking at a very, very quick cut. That's going to take not even 5 minutes to generate those files. Because a lot of people would say, well, hey, I could have got out my X-Acto knife and my ruler and done the same thing. Well, you absolutely could have, but I found it much faster to do it this way because it does not take long to generate those footprints once you've used the software for a bit. And also I have the file saved. So if something happens to those cardboard footprints, if they get chewed up or if I get them full of paint, I can very quickly produce another set. So this you might recognize as a side of a caboose. And what I've done here is James and I got together and we were figuring out how to export vector files from his 2D CAD software. And so for doing so, that he did a set of drawings up for a Canadian National caboose, which is, of course, the wrong railway, but I allow it because James is a good guy. So what we've done here is all these lines were generated by James with his 2D CAD software. But of course, I wanted to scribe the blue lines and do a cut on the outer lines and the lines for the windows. So again, I've used the layer feature, and the engraving is running at 2,000 millimeters per minute at 80%. And this time, because the material that I was using is much thicker than cardboard, I had to slow things down to 500 millimeters per minute. Now, this highlights one of the great advantages of a CO2 laser and its very high power. In a CO2 laser, I could use much, much faster speeds to do this cutting and engraving because the laser light itself is much more powerful. So now this file would generate, it takes about less than 10 minutes to generate that file for sure. Now, this is another screen, and this is where I set the speed and the power. And if you look about a third of the way down, you can see the number of passes. So I can set it from 1 to, I think it'll go up to 100, but I don't know what you'd ever be doing. Now, just a few lines below the number of passes is the kerf offset. This is a very wonderful feature of Lightburn. Every time you cut a piece of material, be it with a laser or an X-Acto, well, not an X-Acto knife because you're not really, anyway. Let's say a table saw is a much better example. If you've ever used a table saw or even a skill saw, as we call them, you know that the kerf of that is about 1/8 of an inch. That's 1/8 of an inch of material that is lost because of the width of the cutting head, no matter what it is. So if you want a precise piece of material, you have to allow for that kerf offset. And Lightburn allows you to adjust for that. Either if you're doing a cut where it's important to have the inside dimensions correct or the outside dimensions correct. And you can see on the right to that, it says outward. And you can see that the kerf offset is 0.15, which, depending on a few factors, is the kerf of a diode laser, which is very minimal. So this shows exactly what the laser is capable of. It cut out the window openings to the precise measurements that I gave it. It cut out the outside to the precise measurements. And it also cut all of the scribing for it. And how accurate is it, you ask? Well, we scaled it out, and this caboose, I think, is 29 feet. Oh, I can't remember. I forgot to write it down. Anyway, it converted to 104.29 millimeters, I think. And as you can see, this actually come out at 104.59 millimeters. So I was approximately 2 millimeters off, 0.2 millimeters off from exact scale in HO. And that is a few inches, if that, in HO. And as James says, you just can't do that, cutting a piece of scribe siding with an X-Acto knife or any other method that you use to cut it. Another practical application of the laser is shingles. We all know that our favorite Campbell shingles are now unobtainium because Campbell has gone out of business. James, in his design and construction of his Apahawk station, designed some shingles to be laser cut because his friend Al in Ontario has a laser machine. And so what he did was set up a size equivalent to an 8.5 by 11 sheet of paper. And as you can see that these are random width shingles, very similar to the Campbell type. And by running this file on a piece of paper, because the laser, of course, can cut paper as easy as anything else, you generate a sheet of shingles. And here they are. Those are the actual shingles as cut, HO scale, on an 8.5 by 11 piece of paper. And from there, you just take them off the paper, There's little tabs on each end so it doesn't all fall apart. And you simply glue them to the structure of your roof. Another feature is HO scale brick. I simply looked up the dimensions of an HO scale of a brick, and I put that into the Lightburn software and duplicated it a whole bunch of times. And I was able to generate this small brick wall. And you can see by the ruler there that these are indeed very small and HO scale bricks. And of course, when your friends are all CN modelers, you get a little bit antsy. So I also created a CP rail coaster, trivet, whatever you might want to call it. And that is simply a white tile left over from a bathroom renovation. And again, one of my good friends donated the leftovers to me, and I engraved that with my laser engraver. And I've made all kinds of things like this for sale at craft shows, etc., with, crazy things like birds and hummingbirds and all that kind of thing, all the stuff the ladies like. Resources. Just a very few brief resources, and if you want these, please email me or ask James and I can email them to you. The first one is designing laser cut structures with Adobe Illustrator. Now, there's a fellow on YouTube, and his name will eventually come to me. You probably already know it. Anyway, he's an ON30 modeler. The Thunder Mesa Lines is the name of his railway that he does. And he did a video on using Adobe Illustrator and a diode laser to create a structure. And basically, he's doing it the same thing as any one of us would do when you scratch build a structure. You take the dimensions, you lay it out onto your wood, and with whatever method you use, you cut it out. Instead, though, he is using made drawings with Adobe Illustrator. You could do the same kind of drawings right in Lightburn and use the laser to cut the scribe siding, etc., that he needed to make his structure. There is a good video on the Xtool D1 Pro 20-watt laser engraver. That's that link there. It's what actually a review by a very knowledgeable woman who is familiar with laser engravers. And she really puts it through its paces and shows you exactly what you can do, the limitations and the strengths of the D1 Pro. And she uses a D1 Pro, but really it shows what a 20-watt laser can do. Because any of the manufacturers' brands that you buy, certainly a 20-watt laser is a 20-watt laser. There's not going to be a lot of difference. The third link that I have there is the Louisiana Hobby Guy, and he is an expert on the Lightburn software. He knows that software inside and out, and I like to browse through his videos, both when I'm looking how to do something specifically and just for ideas, because he can use that software to do some great effects, and he knows a lot of tips and tricks. He is, in my opinion, the best guy out there. He's got a great teaching ability as well to teach that kind of that software. And for materials, Laserboard. They're a company that just sells materials to stick in your laser to do things. And that includes thin plywoods. Birch plywood is the most popular plywood that is used in laser engravers. Acrylic, extruded acrylic for laser engravers and cutters. And also some stuff called Laserboard, which is actually a resin impregnated material that is used for kitchen cabinet backers, but it's been discovered that it also makes great material to stick in your laser. And the wonder of it is it comes in some very, very thin materials. And as I forgot to mention today, which I mentioned in the last time, styrene is not the best thing to put in a laser. But this laser board that's resin impregnated is great, very thin. You can get some very thin materials like 15 thou to put into your engraver to do things like window frames and that kind of thing. And just before I quit, I will give my little speech on styrene. Recently, a few weeks ago, one of the popular YouTube video model train guys, DIY and Digital is the name of his channel, did a thing on laser engravers. And one of the things that he suggested was to use styrene with it. But styrene is not something that I would put through laser engraver because it does not cut, it melts. And whenever you melt styrene, you know how it stinks. And even with a good ventilation system, you're not going to ventilate 100% of the aroma and vapors. And so then you're breathing them in. And that's just not something that I would want to do. So I would highly caution against using styrene in a laser engraver, especially a diode laser. And we've come to the end of my presentation, and I would invite any questions that anyone might have.